Solar panels lose up to 85% of solar energy. A big part of this problem is due to solar panels not being able to track the sun as they move through the skyline. Our initial goal was to design a sun-tracking solar panel system mounted on a roof that could not be blown away by the wind.
I'm Shrikrisha.
This is Alex Louis.
I am Neeraj.
This is Sofiane, and in this video we will introduce you to our ME154 and ME106 joint project, the roof-mounted sun-tracking solar panel. Our design features a 4-bar linkage with an elongated coupler link. The coupler was geometrically designed to carry the weight of the solar panel, articulating it between the angles of 0 and 40 degrees, and placed on a 30-degree slope.
According to the kinematic analysis conducted later, the range of motion of the crank link was limited between 60 degrees and 80 degrees. This was later changed as we eliminated the lower section of the coupler link. The crank link now has a range of 55 degrees to 80 degrees, where the top edge of the solar panel is about 7 inches from the rooftop surface. For the force analysis, we estimated an acceleration of 0.25 radians per second squared. From this, we analyzed individual forces on the joints and attempted to determine the amount of torque required at the crank link to rotate the solar panel to the appropriate angles. The force analysis showed forces of 60 newtons at major joints and a required torque of 2.76 newton meters. Taking this value, two 25 kg 4 cm servos were purchased capable of providing a total torque of 4.9 newton meters, providing us with greater flexibility in adjusting and developing our mechanism.
The two 4-bar linkage assembly was completed with 3D printed PLA linkages, with a thickness of 1/16 inch, connected together with 8mm ball bearings and bolts to reduce friction. Washers were glued on to limit movement and to also serve as failure points. The servo's arms were mounted directly onto the crank arm to control the tilting of the panel. The whole mechanism was mounted on top of an acrylic plate, which is mounted on a rotatable servo base using various bolts and nuts. Additional bracing were added across the two coupler links to increase rigidity of the assembly.
To ensure the proper functioning of the system, a stress analysis was conducted on the links made of 3D printed PLA, a brittle material. Given the forces from the force analysis, the stress analysis revealed a minimum factor of safety on the crank link of 1.74, indicating a relatively safe design. The factor of safety on the coupler and rocker arms were significantly higher at 4.25 and 9.51 respectively.
The following video demonstrates the operation of our prototype, which successfully follows the light as it moves across in different directions.